Good afternoon, everyone, and welcome back to the Suburban Rifleman. This is my Mosin Nagant Model 9130. Some of you may have seen it in an earlier video where I talked at somewhat great length and took a very close look at this rifle, so I'm not going to get too far into it. But this is a 9130 made in 1936 at Tula, and it is empty and nothing in the chamber, nothing in the magazine. This is a rifle that's never been arsenal refinished. I'm pretty sure it was a veteran of the Spanish Civil War for reasons that I already enumerated in that other video. If you want more details on that, I suggest you go take a look at that. But a couple of months ago, I did a shooting video with some Czech training ammo, and I went into it at some length there. Basically, this features a 45 grain hollow core pistol bullet, for lack of a better term. It's very similar in shape to the bullet that you'd have in a .30 carbine, but it's completely hollow and it only weighs 45 grains. But as I talked about in that last video, this ammunition will shoot almost dead flat out to 200 yards, and that's because the Czechs are actually beyond 200 yards. The Czechs loaded this with a full power load in the case. So the whole idea behind this bullet was that it would come out at very, very high velocity and shoot flat out to 200 yards, but then very quickly lose velocity and dive into the dirt. It's kind of unique in that respect. Most training ammo was low power stuff. This is very high power, but again, a very light bullet with a very terrible ballistic coefficient, very low sectional density, really not designed to do anything with. However, it occurs to me that with sufficient velocity, even a very lightweight and very inefficient bullet can do some very serious damage. And I've always been interested in just exactly what this ammo was capable of. So I have here a 25-pound block of lead. I believe this was radiation shielding. It came from the old state hospital. And I also have a block of cast iron. Both of these, this is a little bit less than an inch thick. This is a little bit more than an inch thick. And I want to try shooting this stuff at these two targets, for lack of a better term, at very close range and see, what this tiny little tin can traveling at high speed is capable of at very short ranges. But first thing we have to do is determine just how fast it's going. So I'm on vacation at the moment. I'm at my parents' house in Maine. And just for YouTube's sake, we are shooting at a safe range here. This is private property. I've got a nice slope out behind here. This is training ammo, which is not designed to be dangerous at long range. As a matter of fact, it's specifically designed not to be dangerous at long range. And everything we're doing here is in accordance with proper safety rules. That's just for YouTube's benefit. It wasn't really for your guys' benefit. But I've been fighting with YouTube trying to get my channel monetized, even though I haven't really violated any of their rules. So I've got a chronograph set up here. I've got my readout here. I am 500 miles from home, and I only brought 10 rounds of ammo with me. So we're just going to fire 3 rounds over the chronograph and see what kind of results we get. So, fire in the hole. Error. Alright. I might need more than 3 rounds to get a decent reading out of this. Let's try it again. error again. I guess we'll stop the video at this point and see what the problems are. Okay, so I have slightly repositioned myself. Let's try this one more time. Make sure I'm right over the center here. $3,632. That's pretty damn fast. We'll try 2 more. That'll allow us to still have 5 rounds for shooting at stuff. Very carefully aligned over the sensors. $36.60. Still damn fast. $36.88. Okay, that's enough data. We know that these bullets are going to be cooking along at a pretty good clip. So now let's adjourn to a slightly different location, and we'll take some shots at these things and see what kind of penetration we get at just about 5 or 7 yards. Okay, so we're out here in the woods, and once again, just for YouTube's benefit, this is a safe range. We are adhering to all safety practices. This is private property. We've got a nice hill out back here, and this is training ammo, which is designed to be safe. So anyway, I set up my iron plate over here, and I set up my lead plate as well, and it is the 2nd week of May. You may be able to see the black flies out here are absolutely atrocious. So what I'm going to do is I'm going to fire, I have 5 rounds of ammunition. I'm going to fire 2 at the iron and 3 at the lead plate, and then we're going to get the hell out of the woods and away from these flies, and we'll examine the results of our shooting back at the house. Here we go. Rifle's clear, range is clear. Let's wrap this up. We'll take a look at the stuff back at the cabin. So here you can see the results of our little shooting experiment. I have to admit, I was expecting things to be a little bit more dramatic. There was another guy on a YouTube channel shooting these same Czech training loads at a 1/4-inch piece of mild steel, and I mean they punched right through like a drill press. And cast iron, which is what this is just a piece of scrap from a project we were working on. Cast iron is quite a bit softer than even mild steel, but this is quite thick. It's not super consistent, but when I measured this, I think it averaged out at about 7/8 of an inch. And you can see both of these rounds only penetrated into the surface of the iron about, I don't know, 1/4 of an inch, maybe 1/2 an inch. So I guess the bullet jacket just kind of broke up on the surface there. You can see the crystalline structure on the surface here, but down at the bottom of the craters, there was definitely enough heat transfer to sort of slightly melt the iron. So you've got these shiny bottoms of the craters, but it didn't even try to go all the way through. There is a bit of cracking here, but nothing too terribly significant. So that definitely stopped those bullets. Our lead radiation shielding is a different story. Now this is about 1 1/8 inches thick. We did have it crack all the way through, although the bullet didn't penetrate on one shot, and there's pretty good dents on the other 2 shots. But very, very dramatic cratering on the front of the lead block. You can still see there's still a few black flies here, nothing like down in the woods, but one of them was just biting me in my ear. But there was definitely a lot of heat transfer here. You can see this blob of molten lead in the bottom of this crater, and in this one, and to a lesser degree in the bottom of this. And these went in about I don't know, 3/4 of an inch or so, but kind of reminds me of Terminator 2 when Arnold Schwarzenegger shoots the liquid metal cyborg with a 12 gauge. Kind of what I was looking for. I'm a bit surprised that it didn't go all the way through, but still pretty cool results. Anyway, this was just a dumb little video for the first day of vacation. I got 7 days ahead of me. I'm going to try to shoot a bunch of other videos at the range in the style that I normally do. And I hope to see each of you here then. Later, guys.